So this is the Waves Homework Booklet question 10. We've got a figure showing a continuous progressive wave on a rope, and there's a knot in the rope. There's the knot. And the first question, straightforward definition, define the amplitude. The amplitude is the maximum displacement from the equilibrium position. We're then told, as was shown in the diagram in fact, that the wave is travelling to the right, and we've got to describe how its vertical displacement varies over the next complete cycle. So the way I would think about this is with the wave travelling to the right, the next feature that's going to arrive is this minimum, so that's going to take a quarter cycle. So for the first quarter cycle, the knot is going to move vertically downwards to that maximum negative displacement. Then that equilibrium position will have reached where the knot is, and then that maximum. So for the next half cycle, it's going to move upwards to the maximum positive equilibrium position, moving through the equilibrium position on its way. And then finally, this equilibrium position there will have travelled all the way and reached a position where the knot is. Remember, it's a transverse wave. All the knot, a particle on the medium can do is move perpendicular to that direction of the wave movement, of the wave travel. And so the knot is going to return back to the equilibrium position. So for the first quarter cycle, it's moving downwards to the maximum. For the next half cycle, it moves upwards. And for the last quarter cycle, it's going to be reaching the maximum positive displacement. And the last quarter cycle, it's going to move downwards back to the equilibrium position. If you look at this, even looking at that direction of the wave movement, and you can't work out which direction it's going to go, it's worth just drawing it again sometime, but no more than a quarter of a cycle, so time a little while later. So if the wave's moving, if that wave is moving to the right, then a little while later it's going to look something like this, or indeed something like this dotted green line, and therefore I can see that it's going to have to end up there. Therefore, given that all it can do is move up and down, it has to be moving downwards to start with. Finally, we've got a continuous wave of the same amplitude and frequency moving along the rope from the right and passing through the wave. The knot becomes motionless, key thing to put up, and you need to explain how that can happen. Well, the knots become motionless because we've formed a stationary wave because of the superposition of those two progressive waves travelling in opposite directions. And what that's going to do is and therefore that knot must be at a node, which is a place where the two waves continuously and all the time cancel each other out. So we've got a stationary wave forming by the superposition of the two progressive waves. The knot must be sitting at a node where those two waves cancel each other out. So that's the Waves Homework Booklet question 10.